Good morning, ladies and gentlemen. Welcome back to the Math Show. Today we are joined by Professor Sinusoidal from the University of Satek and world-renowned mathematician, Omar Zedifig. They're here today to help us explore a very interesting phenomenon, the sunset. Professor, why don't you tell us a little more about the sunset and patterns in sunset times?
Well, the sun sets every day, and if you pay careful attention to the timing of each sunset, you will see that every day the time changes by about a minute or two. In fact, we have a graph with the times of the sunset.
But how do we know that the sunset times can be represented by a sinusoidal function?
Science, my friend, science. Due to the tilt of the Earth on its axis, this causes the track of the sun in the sky to change as the year progresses. The winter solstice on December 21st is the shortest day and longest night of the year. After these days, the days get longer and nights get shorter.
And in June, when the summer solstice occurs, the days begin to get shorter and the nights get longer, until the next winter solstice. That's when the cycle repeats. Therefore, the sunset times can be represented by a sinusoidal function.
Exactly. The data shows the cycle throughout the year having regular intervals.
Let us have a look at the data, shall we? The data comes from the year of 2014, the times collected in our geographic location, Toronto, Ontario, Canada. Now let us take a look at the graph that was generated using this data. Professor Omar, will you do the honors of explaining what this graph is?
This graph represents the sunset times over the period of a year. As you can see, the sunset times in January and December are quite low, meaning that sunsets occur early during the winter season. Sunsets around the summer, such as during the season of June, are represented as quite high on the graph, meaning that sunsets occur later in the day during these seasons.
I see. Well, Mr. Sinusoidal, is there a way to calculate a pattern in this remarkable occurrence?
Why, yes. This graph is what we classify as a periodic sinusoidal function. The equation of the axes is 6.875, which we figured out by adding the peak and trough, and then dividing by 2. This will be our C value. The amplitude is 2.175, which we found by subtracting the trough from the peak and dividing by 2. This will be our A value. The period of the function is 1 year, and since we are using months as our X value, we will do 360 divided by 12, which is 30. So our K value will be 30. Finally, there is no D value because there is no phase shift. This gives us an equation of y equals negative 2.175 cos 30x plus 6.875.
Very interesting indeed. Oh boy, would you look at the time? It is about time for question period. Omar, what happens when the sun sets too early or too late?
Well, that's why we have daylight saving time. As the name suggests, it allows us to change our clocks 1 hour earlier or 1 hour later to observe the same amount of sunlight each day without a huge difference.
I see. How would the graph change if we used sine instead of cosine?
Well, the only thing we need to change is the phase shift, or the D value.
Well, that was a great show we've had today. I hope the viewers at home watching learned a thing or two about sunset times throughout the year and how the data can be used to calculate the amplitude, period, equation of axis and phase shift in order to generate a sinusoidal function. See you all again next time.
Using Powtoon.